Hi everyone. So today we look at solving circuits with dependent sources using loop and nodal analysis techniques. And by the end of it, what I hope you should be able to do is to write the systems of equations that define the system. We're not going to look at the complete solution. You could do that in any MATLAB or Scilab, and I'll show you how to use MATLAB and Scilab to work out your matrices and so on shortly. So you could use those sorts of software to get around the mathematics. The important thing really is that the equations that define the system are correct. So let's look at one example, and we will do this using both the loop and nodal techniques. So I'll get going first with the nodal technique. And the first thing we're going to do here is we're going to identify our nodes as usual. So we know that this is 1 volt here. This is the node all the way here, and this is 1 volt. And then we have VA, and we have another node here, VB. So I could start right away writing my nodal equation for VA. Let me put that a little further. VA, the VA node, and I'm going to take all the currents going in to the node. So it will be 1 minus VA on 3, which is the current going this way, plus the current going up through this resistor here, which is 0 minus VA on 5, plus the current coming in through this way, which is VB minus VA on 4, and all of that is equal to 0. Next, I have to write it for VB. So for VB, I have now a current coming in this way, which is 1 minus VB on 6, plus the current coming in this way, which is VA minus VB on 4, plus the current coming up this way, which is 3Vx. Notice, even though this says Vx, which is a voltage, it is a current because we can see the symbol here is a current source. What this tells us is that the value of this current is 3 times the value of Vx, and Vx is across this 5 ohm resistor. So all of that is equal to 0. So now I have to get Vx in terms of my node voltages, because that is what I'm trying to solve in the system. So I look here at Vx, and I can see that Vx is VA minus 0, which is VA. So Vx is equal to VA minus 0, which is VA, which means I could write the equation here as 1 minus VB on 6 plus VA minus VB on 4 plus 3 VA is equal to 0. And now I have 2 equations, 1, 2, and 2 unknowns. So I could solve the system. Now I could do the same thing using loop analysis. So let's look at how we'll do it using loop analysis now. So let me just erase all the nodes, and we're going to start to draw in some loops. So I'm going to start drawing in the loops. I'll call this I1, I2, and I3. And I'm going to start writing the equations for all of these loops. So for the I1 loop, Notice these are colons, they are not equal signs. That is a common mistake that students make. They put I1 equals to something or VA equals to something. This just means it's the I1 loop we are looking at. So if I take the, if I sum the voltages around the loop, first I draw in all my arrows. And I start at this point and I'm going to go around the loop this way. So it is 1 minus 3 I1 minus I2 minus 5 I1 minus I3 is equal to 0. I2, I'm going to start at this point here and go around. So it is, for I2 it will be minus 6 I2 minus 4 I2 minus I3 minus 3 I2 minus I1 is equal to 0. And then for the I3 loop, the I3 loop covers this current source, and it is the only loop covering the current source. So I could say here immediately that I3 is equal to minus 3 Vx. Now notice I have again a condition where I need to find the voltage across here. But the difference now is, whereas in the nodal analysis I had to find Vx in terms of the node voltages, here since I'm working with the node current, the loop currents, I have to find Vx in terms of the loop currents. So if I look at the circuit, I'll see that Vx is this resistance, which is 5, and the voltage drop across that is going to be given by the current that flows through it. So this is minus 3, and the resistance multiplied by 5, and the current through it will be I1 minus I3. And of course I said I1 minus I3 and not I3 minus I1 because of the direction of the voltage drop we're looking in. Since since the voltage drop is this way, from positive here to negative, it means that this current will give you the direction of positive voltage drop. So now I have my 3 equations and 3 unknowns. I have one equation here, 2 equations here, and this is the 3rd equation. Now I can do the same thing if I replace the current source with a voltage source. So before I had a current source here, I just took it out and I replaced it with a voltage source, and this time the voltage source is dependent on this current here. So I'm going to go through the same processes again. I'm going to look at the nodal analysis and then the loop analysis. So now we could identify already that this is 1 volt, and since this is a voltage source now, I know that this is 3ix volts. So I only have one node which is unknown, so I'm going to call this VA, and I'm going to write the equation for VA. So taking the currents coming in, I have 1 in this direction, 1 minus VA on 3 plus this direction, which will be 0 minus VA on 5 plus the current in this direction, which is 3ix minus VA on 4, and all of that is equal to 0. Now again, I need to find Ix in terms of my my nodal voltages. So here I have to look at what is Ix in terms of the different voltages at the nodes. So I can see here that Ix is equal to 1 minus VA over 3. And now I have two equations and two unknowns, and I could solve the circuit for VA and Ix as well. If I do the same thing now with the loops, I'm going to erase this and I'm going to draw in my loops. So I'll pick the same loops again. I1, I2, I3. So I'm going to write the equation for the I1 loop, and this time I'm going to go around the other way. So it will be minus 1 plus 3 I1 minus I2 plus 5 I1 minus I3 is equal to 0. For the I2 loop, I have 3 I2 minus I1 plus 6 I2 plus 4 I2 minus I3, and that is equal to 0. And then lastly I3, I have 5 I3 minus I1 plus 4 I3 minus I2 minus 3ix is equal to 0. And here now I have to find an equation for Ix. But unlike this equation, which gives me it in terms of the node voltages, here I'm working with loop currents. So I have to write the equation in terms of the loop currents. So here I see Ix is a combination of I1 in this direction and I2 in this direction. So I could simply say Ix is I1 minus I2. And now I have 4 equations with 4 unknowns, and I could solve it. So in summary, we looked at writing the systems of equations for circuits containing dependent current sources and voltage sources using nodal and loop analysis. And remember, we only did 2 of them. There are 2 other variations. You can have voltage controlled voltage sources and current controlled current sources in addition to the ones we did, but the same theory applies. It's the same process. You treat them as a normal voltage source, and then you have to substitute the value for the relevant variables that you're solving for.